Students, hope you all had a really relaxing weekend. It was pretty nice. Got outside, stayed away from people. And what we are going to work on today is our coordinate geometry proofs. A couple of things, though, to keep in mind is first, there's a lot of work that you guys can start getting on and doing, both on Delta Math and also Castle Learning, and not Castle Learning, that's a different class, on Delta Math and on cimath.com. So this week we only have 2 live videos going on, today and tomorrow, and then from there's 2 days of review, and that will just post videos of the answers. And then maybe either Thursday night or Friday, we'll kind of get an idea of what you guys want to do. We'll have maybe just like an extra help session, answering any questions, and then you guys are going to have a test that you're going to have to complete. Okay, so you have some work to do, so please get on to deltamath.com. You can use our teacher codes, all of those, whether you're with myself or if you are with Miss Holden. If you go to cimath.com, and you'll see right here, Delta Math codes, that's for myself, and there's Miss Holden, and then there's a how-to video if you're still a little bit lost. So make sure you get on there and get those things done as well. All right, so without any further delay, let's do some coordinate geometry proofs. Now, what we're going to be doing today, there's literally nothing new. Good. If you have your rules for parallelograms memorized, awesome. If you don't, then get back on the last video and make sure you copy down all of the notes on parallelograms, on quadrilaterals, so that you understand all of the rules. Otherwise, you won't be able to get them. And it's coordinate geometry, which means that we're going to be doing this from the coordinate plane. So let's start. So it says, prove that parallelogram RSTU is a parallelogram using coordinate geometry. So in order to do that, you need to know your rules for parallelograms. And that is that the opposite sides would be parallel, that the opposite sides are congruent, and that the diagonals bisect each other. So those are all ways that we can do it. So from here, if you didn't want to use any of your formulas, what you could do is you can count everyone's slope, where the vertical distance and then the horizontal distance, and then that would be 3 up and 9 to the right. And if you were going to do TU, it would just be 3 down and 9 to the left. If I was then going to go and look at RU and ST, again, remember, make sure you're always doing vertical and then horizontal, because slope is always y over x. And we would be doing 5 up, 3 to the right, 5 up, 3 to the right, or 5 down and 3 to the left here. Now, what will this do for us? Well, this, if I'm using slope, remember, if you have the same slope, you know that your lines are going to be parallel. Yeah, a lot of you are probably going to start missing, and the longer we're home, the more you're going to miss it. So you don't realize how good things are until they're actually missing. Okay, I'm not going to lie, I'm also missing being at school. So RS, 3 over 9. Now that could simplify to 1/3. And UT, it was the same thing, 3 over 9 or 1/3. If you are going to use now, let's see, UR, that would be 5 over 3. That stays as 5 over 3. And ST, now if you were using what we had there, which was -5 over -3, 2 negatives make a positive. So now what we can say here is opposite sides are parallel. Now, believe it or not, that's not enough. If you're going to do this, then we also have to show that there's a pair of opposite sides that are also congruent. Just use the numbers you have here, okay? If you're not using your formula, which you don't need, you could just use those numbers. So if I did RS, I could just use 3 squared plus 9 squared. UT were the same numbers. And again, if you were using your negative, it's always good habit, because if you didn't, you're going to get a different answer, to keep those in parentheses. Okay, and then 3 squared plus 9 squared would be square root of 90. So opposite sides are parallel, and we just showed that one pair of opposite sides were also congruent. So now we know that we're a parallelogram. If I was doing the same thing, I could use, or if I did RU, I would be using these numbers here of 5 squared and 3 squared, which would be square root of 34. And since ST had the same numbers, he's also the square root of 34. So opposite sides are parallel, opposite sides are congruent. Therefore, we have a parallelogram. Now, that's not the only way. We could also use the diagonals. So if I drew diagonals here, what's true is diagonals of a parallelogram bisect each other. So if they bisected, what is this? They're going to share a midpoint. So you could find the midpoint by using either the formula, or remember, you could always count it. Count your distance from U to S, cut it in half, and then count that distance, and that would be your midpoint. But for the sake of this problem, let's go ahead and use our midpoint formula. So we'll start with RT, and remember, it's x1 plus x2 divided by 2, y1 plus y2 divided by 2, and that's your midpoint formula. So if you're going to use point R and point T, I would have 0 plus 6, that's a 0, divided by 2, and we have 3 plus 1 divided by 2, and then that midpoint ends up being 3, 2. Now the same thing if I'm going to use point S and point U, which would be 9 and negative 3 for my x values. And I would be using 6 plus negative 2 divided by 2. And that gives us the same thing, 3, 2. And as we just talked about before, since they share a midpoint, the diagonals bisect one another, therefore it's a parallelogram. So both of these ways would work, just whichever way you start to feel more comfortable with. So there you go for question number 1. So those are different ways to solve it. Yes, so this is the first way that you could do it, and this is the second way you can do it. So either you would show opposite sides are parallel and congruent, okay, you need to show one pair, or you can show that the diagonals bisect one another, and that's another way to do it. Okay, so that's just for a parallelogram. Now let's look at exercise 2, which gives us here another quadrilateral, and it says calculate the slopes of all 4 sides. Use the slopes to prove that EFGH is a rectangle now. So now again, it goes back. It's still all of the same rules as a parallelogram, but what is the big difference? The rectangle, we better have 90-degree angles. Okay, whereas the last one, if you look at the parallelogram, we don't have 90-degree angles. Why would we use slopes for a rectangle? Because the slopes would have to be negative reciprocals. So let's see if we can do that. So we have all 4 sides. So we have side EF, we have side FG, we have side HG, and we have side EH. So again, you can go and you can count your vertical distance and your horizontal distance for each one of these sides. So real quick here, this would be a vertical distance of 6, and this would be a horizontal distance of 9. Remember, when you're writing the slope, always do the vertical over the horizontal or the y over x, and then that's going to simplify as 3 over 4. And then if you're doing FG, okay, FG here, nope, I lied. That's 2/3. I was doing 2. That's going to be 2/3. Okay. HG, if you did it correct, better have the exact same slope, 6 over 9, or 2 over 3. Now when I go to count FG, I would be counting vertical and horizontal distance. So if I'm going this way, I would be counting 6 up and 4 to the left. 6 up and 4 to the left, and then that is 3 over negative 2. This would be the same thing, 3 over negative 2. As we said now before, if we're looking at opposite sides, EF and HG, they have the same slope, so they are going to be parallel. But now what we're doing here is, since we're looking at a rectangle, take a look at these consecutive sides of EF and FG. EF and FG. Their slopes are 2 over 3, and his negative reciprocal was negative 3 over 2. That's how I know that this is a rectangle from that 90 degrees. Okay, next one. Calculate the midpoints of the diagonals. Why does it show that EFGH is a parallelogram? So take a second while I set this up. Well, what has to happen with the midpoint for it to be a parallelogram? Each diagonal better have the same midpoint. Each diagonal better have the same midpoint. So you can either use your midpoint formula, or you can just go ahead and count out the slope between the two. Okay, you can count out the distance from here to here, vertical, horizontal. Same here, vertical and horizontal. Or you could go ahead and use your midpoint formula. So it should be right around there. Well, if you're doing it at home, use a ruler, okay? And we'll find out if they intersect in the same spot. So if I'm starting with EG using my points would be negative 6 plus 7 divided by 2, and it would be 2 plus 2 divided by 2. And that ends up being 0.5, comma 2. And my sketch pretty much shows that I am right there. FH, or is that okay? EGFH is going to end up being the same exact thing. FH is going to be 3 plus negative 2 divided by 2, and 8 plus negative 4 divided by 2, which is 0.5, comma 2. So they share the same midpoint. Now that shows that he's a parallelogram, not a rectangle. So what is the difference for diagonals between a parallelogram and a rectangle? Well, for a parallelogram, the rectangles are not congruent, but for a rectangle, the diagonals are congruent. So if I find the distance of each one of these, then they should be the same. Therefore, again, now you're a rectangle. And if you're counting distances, or vertical and horizontal, okay, it's about 12 up, 5 to the right, 12 up, 5 to the right. Okay, and then they're both going to be the same, okay? 12 squared plus 5 squared, that's about 169, which is a distance of 13. Now, this one's nice because you can it's 3, 4, 9, 10, 11, 12, 13, and EG, just from counting, since it's a nice straight line. So since why, along with B, does this show that it is a rectangle? Well, the midpoints share, so they bisect each other. The diagonals are congruent, therefore you're a rectangle. Okay, and then the exercise 3 and exercise 4 are very similar in that they are asking the same thing, but just with different quadrilaterals. So now we're looking at a rhombus. So what do we know about a rhombus? Well, a rhombus, all sides are congruent. But who else has all sides are congruent? A square, okay? So in this one, you're going to make sure to show a rhombus that your sides are not going to be that. Or, remember, for diagonals are perpendicular, you can go ahead and find the slopes of your diagonals and make sure that they are also negative reciprocals, okay? Okay, so I'll just kind of sketch this, and you guys can do it a little bit more in depth on your own. So let's see, number 3, when I was doing it earlier, okay, I was finding my distances to be 7 and 4, or my slopes, okay, so this is not what it looks like, but your distances here were 7 and 4, okay, and then if you're using your distance formula, you should have a 7 squared and a 4 squared, so squared 65. And you would need to do this 4 times. Okay, you would want to do that 4 times just to make sure that all of the sides were congruent. Okay, diagonals A, B, C, D are perpendicular, so you'd want to count your distances or use your slope formula to find both of theirs. Okay, and then what I did was, once I found the slope of BD, I had -2/3, and AC was +3/2. And there you go. That would show that. So when you're doing this, make sure you get it. If you're not getting it when you're doing it on your own, again, you can either leave a comment or send me a remind, or whatever way you want to communicate with me best. So if you want, you can pause the video, go ahead and do it as I finish these last couple problems. Says prove that EFGH is a rectangle. Okay, and again, there are a few different ways that you can do that. Okay, here's our rectangle. How do I know I'm a rectangle? Opposite sides are going to be congruent. Opposite sides are parallel. But you got to be careful, because that's also true for a parallelogram. So then also show me that one of your angles is 90. Or, that would be one method. You can use your 2 diagonals, and you would show me that the diagonals share a midpoint, and that would show bisect, and show me that you're using your distance formula, that you have a equal distance between the two. The 4 isn't negative. It doesn't matter, because 4 squared and -4 squared is still going to give you 16. So, and 7 squared is 49. So the question was, isn't the 4 negative? Well, if I went up 7, right 4, if I came over here, if I went down 7, left 4, it could still be positive or negative. Okay, either way, because you're squaring it, you're always going to end up with a positive inside for your distance formula. If you have a negative, then you're in big trouble. Okay. And again, the answers for all of this you can also find on cimath.com if you just want to look at the answers. Okay, and just go to the answer section from there. Okay, so when I was doing this one, so I had EF, and I had the slope to be -1/3, the distance to be 160. Okay, HG, or the square root, I found also -1/3. His distance was the same at 160. When I did FG, I found his slope to be 3, and his distance to be the square root of 90. And which side am I missing? EH. His slope was 3, his distance was 90. So you can see opposite sides are congruent and parallel. And then if I take this slope, -1/3, it is perpendicular to his slope of 3, or 3/1. Okay, 5, parallelogram, just like we just talked about. Okay, you could find the distance, opposite sides, all that great stuff for that question there. And now to find that it is not a rhombus, okay, to find that it is not a rhombus, what you would want to do is show that, well, I think the easiest way to do it is, since the opposite sides are not, all sides are not congruent, then it's not a rhombus, since you most likely did that up here. Okay, or you can go ahead and do the diagonals and show that the diagonals are not perpendicular. That's another way to do it. And then the last one here, prove that ABCD is a square. Every single rule applies here. All sides would be congruent. Show me that you have a 90 here. Okay, you can show me, okay, with the diagonals. Okay, the diagonals here, that they are congruent, they're all going to be the same, and that you're going to have a bisector. So pretty much all of the rules would apply here. Okay, if you think about it, it's kind of the same rules or the same way you did a rectangle, except in the rectangle the opposite sides were congruent, where the square all of the sides are going to be congruent. Okay, so if you have any questions or comments, please leave that for me. CImath.com, you're going to find everything. Don't forget also there's a lot of quizzes that you have to do, tests coming up. CImath.com. I am going to do a live tonight around 8 p.m. for those of you trying to figure out how to use Google Classroom, how to set that up with teachers. So let your friends know that that's going to be another resource. All right. I hope you guys all have a great day.